Okay. Great. So then equation of the line in vector form. So how does this differ to what you did in week 1, semester 1? Well, what you have, A, point B, and then there's our origin. So in semester 1, we found the equation of this line. We all know how to do that. It's y equals mx plus c. But now what's different is you don't want the equation of this line. Instead, you want the equation that represents all the different vectors that point to all the different points on the line. So you're looking for an expression that describes all of these vectors that point everywhere and only on the line. So how can we do that? Well, what we'll do is we'll start off with a point on the line and we call it or. So we can say or equals O or. But we're trying to write this without using or. So we can say O or is O A plus A or. OA is A. What about A or? Can we think of anything we can say with A or? In my example, it looks like half AB, doesn't it? Although it doesn't have to be a half AB. It could be 3/4 or 1/4 or whatever. So instead we'll say it's plus T AB. Where T is some number like a half of 3/4. We're not sure. And in fact, that's the equation of this situation here. Every single vector that points on this line can be written like this, where you just put in different values of t. So, for example, if t equals 0, where will the vector point to? Yep. And in fact, when t equals 1, it will point to B. And when t equals a half, it will point to the middle of A and B. So by changing the t, you can change where this points to on the line. So if you want to point everywhere on the line, you need to say t is every real number. So as t goes to minus infinity, the factor goes further away from A, and then when it goes to infinity, it goes further away from B. And then when t equals a half, it's exactly in the middle between A and B. Got that? No?
What's t?
T is like, it's like the x in y equals mx plus c. It's a variable. I'll do an example of this one. Scroll down. Not yet. Scroll down. Yep. No. Oh, come on. Yes? Okay. Well, no. I'm scrolling down now. It shouldn't take that long to write down that. So as an example, here's the first point, 1, 3, 1, and then here's the second point, 2, 0, 1. And I want to find the equation that represents all the vectors that point to this line. So I just use my formula I gave you. Or equals t plus, or equals a plus tab. So that equals a, I'll call this one a and this one b, 1, 3, 1, plus t, and ab is b minus a. Hurry up, Sayun. 1 minus 3, 0. If you want, you can write that as 1 plus t, 3 minus 3t, and 1. And this is the answer. And you can check it. So if you put t equals 0, you get 1, 3, 1, which is A. And if you put t equals 1, you get 2, 0, 1, which is B. And if you put t equal to any other number, you'll get some other place on that line. So this points to everywhere on the line. You just need a different value of t to get a different location. So I'll just put in red here. This one here you get when t is 0. This one here you get when t is 1. In the middle will be t is a half. If you want to go all the way down to this end, you'd have to make t nearly minus infinity, and all the way in the other direction will be t equals infinity.
I'm sorry, did you subtract a and b?
Yeah, it was b minus a, that 1 minus 3, 0. Is that what you're asking me, or something else?
So why can't you write b minus a before?
Oh, you can if you like, yep. Some years I do it, some years I don't.
Yeah, but like this looks like a multiplied b.
Ah, okay, here. Will help. Did you write that down, Curdy? You tired? Too much driving around?
No.
No Brendan? No Joseph? But got Abanoob? Got Abanoob? Okay, let's have a look at another example now. So in this situation, let's put O here, for example. You don't want this line. Instead, you want this line, which is parallel to AB. So you want all these vectors, as an example. Is the formula different? It's a little different, but it's quite similar. So if we look at it, again, let's just call this one here OR. You want OR, which equals OR, which equals OC plus COR, which equals C plus COR. Now what can I do about COR? Any ideas here? Any ideas?
Or minus.
No CR? Come on, wake up time. Half AB. Say that again. TBA. Plus minus. Yeah, close enough. So CR is TAB because CR is it parallel to AB? It is. So it's the same, just might be a different size. So this can be written as C plus TAB, which looks very similar to the other formula I gave you, or equals C plus TAB. Okay. So if we just compare for the moment between the two formulas, they're kind of really the same thing. If you look at the formula, it looks like this. Or equals, you have some point here, I'll just call it x, plus ty. And what does each part do? So how would you describe what this x part does? If you look at your two formulas, what's the role of that first term in the formula? What would you say it is?
Like connect from the origin to...
Yeah, but even simpler than that. You got the right idea, but something simpler. Look at both formulas. What was the first? You're sitting there looking tired and stupid. Please don't do this. Look at both formulas. And look at the first part of each formula. What is the function of that part? What has it done? Where did it come from? It came what? Yeah, go on. So it's on this same line? Yeah. So that first term in the formula is always a point on the line. In both cases. So this one here is a point on the line. And then what about the coefficient of the t? What's the role of that? Not quite another point. It was in the first case, but not in the second one. A bit more general?
Multiplication.
Not quite multiplication. This second vector, if you look in both cases, I think in the first case it was AB, and in the second case it was AB. In other words, it's always a vector that points in the direction of the line. So it's like the direction of the line. So this is the general form. But if you think about it, it makes sense, because if I'm saying a line is this, what I'm really saying is first go to x. X is a point on the line. And then move across the line t units. You know, if you think about it like this, here's x. So I'm saying go to x and then go some t multiple of y. So you get onto the line. You don't have to worry too much about that. I'm just saying that although they're two different formulas, they're really the same formula. It goes point on the line plus t times the direction of the line. So you can see C is a point on the line plus t times the direction of the line, which in this case is AB because they're parallel. Okay, so let's look at an example of this one. So I want to find this line here that goes through 411 and is parallel to this line. So my formula says it equals the point on the line plus t times the direction of the line. So that'd be 3 minus 1, which is 2, 3 minus 2, which is 1, 2 minus 1, which is 1. So the answer is 4 plus 2t. 1 plus t, 1 plus t. Reem, did you write this down? Okay.
I'm sorry, is that 2?
Which one? Here is a 2 and here's a 2.
And then the last one was...
No, that's a t. Yep, okay. So let's see. Let me change this actually to 10 and 4. Oh, what am I doing? Well, make sure I pick one that gives you an answer. 5.
Sorry, is that S?
It's an S, yeah. Okay. Good. Okay. So what we've got here is 2 lines, and on the left here these are an example of the vectors that point on the first line, and on the right is an example of the vectors that point on the second line. Now, slightly different here. In 2 dimensions, like semester 1, week 1, as long as the lines are not parallel, you know that they'll meet. But this is not the case in 3 dimensions, because if you have 2 lines, they might look like they meet, but there could still be a distance between them. So you're not guaranteed that 2 lines will meet in 3 dimensions. In fact, they usually shouldn't, because 3 dimensions is quite big. So 2 lines are not likely to meet. But in the exam, obviously this isn't going to be the case, because one of the things that they test you on in the exam is, can you find out where 2 lines meet, if they do meet? So if these 2 lines meet, how do you find out where they meet? So what I'll do first is I'll just simplify a little bit the first line. So that'll be 4 plus 3t, 10 plus 2t, 4 plus t. And then the second line, I can't use t as well. So I have 2 plus 5s, 1 plus 11s, and 2 plus 3s. So does anybody have any ideas how I could find out the point where these two lines meet? Yeah, just equate them like normal, make them equal. So I'll go back to this, but I'm just going to move to the side to solve that. So don't worry, I'll go back to that main one now. So equating these two, I get 4 plus 3t equals 2 plus 5s. 10 plus 2t equals 1 plus 11s. And 4 plus t equals 2 plus 3, that's 11 if you can't see, s. Although something strange has happened here. How many unknowns are there here? 2, but there's 3 equations. What this means is, in fact, you should only need to use 2 of them, and the third one should match. And what I mean by that is, you should only use 2, and the third one should still hold. So I'll show you, for example. If I take these two, I won't bother, I know what the answer is going to be because of how I made up the question, and I won't bother solving it because it's such a standard thing you should be able to all do now. If you solve these two for s and t, you'll get s equals 1 and t equals 1. What you always need to do, where you get the mark, is not only do you have to find s and t, you need to show that this one still holds with these values. Because maybe you solve s and t here, but when you put them into this, it doesn't hold. So what you've just done there is you've shown that the lines meet in 2 dimensions, but then when you look in 3 dimensions, they don't meet. They have different heights. So if I put s and t is 1 in this, I get 5 equals 5. So they definitely do meet.
Sorry, how do we solve this?
Now, this is 2-dimension system we did in semester 1. You have 3 methods: matrix method, simultaneous, elimination, substitution. Okay, so going back here, if you want to find what the vector is, we just put the answer back in. So t is 1, that would be 7, 12, 5. And then s is 1, this should be the same, 7, 12, 5. So what you've done is you've found that they meet here at 7, 12, 5.
What if you put it there,
Then you have screwed up big time. Because if the question said, show that they meet, and this didn't happen, possibly it's a mistake in the exam. You should ask me. But it's more likely that you made a mistake. I mean, a very simple mistake I could have made here is mixing up my s and my 5. Because they usually use s and t in the exam. So when you're writing your s, you make sure you give that a nice, good kick to it.
Sorry, we solved all 3 of them
Correct. And the question
at
is?
the same time.
No. You just have to pick 2 of the equations and solve them. So for example, you could solve this one and then this one together. Any 2 will do. Got that? Okay, for my next example, I need you to keep these 2, so I'll ask you for them in a minute, but not right this second. Okay, so let's recap what we've been able to do so far. We can find out the equation of the line that joins 2 points. We can find out the equation of the line that contains 1 point and then is parallel to another line. So this is seeming a lot like semester 1. What have we not done yet? So what one yet? Perpendicular. But we don't cover perpendicular here, so we just need to have the 2 we've done so far. Joining 2 points and parallel to an existing line. Okay. Now, here's my first line. Let's just call it x plus ty. And then here's my second line. Let's call it u plus sv. And let's call the place where they meet or. And I would like to find the angle between these. I know there's one point on this line. What's the one point that I know that's on this line? X. And then on this one?
U.
Yeah. So if I want to find the angle between these two lines, I need to use this vector and this one here. So can I try and simplify that a bit? Well, let's see what we can get. Cos theta equals or x dot or u all over or x magnitude or u. Yeah. But if you look at this, you'll realize, well, or x, that's just going to be the same thing as some multiple of y, because y, remember, is the direction of the line. So for example, maybe it'll be 2y or 3y. Remember, y is the direction of the line. So if I'm pointing along the line, like I am in or x, then that can be written as just some multiple of y. So let me just call it m multiple of y. And likewise for or u, it too will be some multiple of what? V. So let me just call that nv, some multiple of v. All over magnitude of y, magnitude of v. But what you'll notice here is the m's and the n's cancel. So in other words, you get this nice simple formula here. Cos theta equals, in this case, y dot v over magnitude y times magnitude v. In other words, when you want to get the angle between two lines, you just need to use the vector that's the coefficient of the t or of the s.
Sorry, could you please repeat the previous step?
From here to here. So what I did was the m cancelled the m here, and sorry, that should be an n. The n cancelled the n here.
What's the V?
And the v is this one here. This is the y, and the v is what I used.
I know, but
What does it represent?
yeah.
V is a vector which points in the direction of the line. So it's like a vector that's on the line. So for example, here V will be looking like it's about southeast. So V is the direction. It's a lot like, where's it gone? Not a lot like, it's exactly like this thing here. Anyways, that's a short little proof to show you that when you want the angle between two lines, the vector you need to use in the formula is the vector that's the coefficient of the t or of the s. So for example, in that last question I did for you, what was the first vector, the coefficient of the t? What was the coefficient of the t?
4 plus the...
No, just give me the t part, the t vector. 3, 2, 1. And then for the other line, the coefficient of the s? 5, 5, 11, 3? Okay. So So I have to dot them together and find their magnitudes. 3, 2, 1 times 5, 11, 3. Okay, so the dot will be 15 plus 22 plus 3 all over square root. 4 and 1 is 5. 5 and 9 is 14. Square root. 121 and 9 is 130 and 155. So that's 25, 30, 40. 40 over root 14, root 155. That's the cos theta. So can somebody please give me cos inverse of this fraction here? In degrees. $30.8 degrees. Okay. Yeah, I used the vectors in the previous example. Or you have a question about it, is it? In my proof or in the actual example?
Yeah, this one.
Here, yes?
My, the second one is M, right?
Yeah, this is just a little proof, so you don't even need this. The point I'm just making here is, if I have this line, which is or equals x1 plus t y1, and I have this line here, which is or equals x2 plus ty2, and I want the angle between the lines, I just need to use this vector and this vector in my formula. Okay, so it's not really an example. Okay. There's something I forgot to mention early. Well, I didn't mention it, but I didn't say it so explicitly. If you have two vectors A and B, how do you think you could work out the vector that's in between A and B? So, like, for example, here's A, and then here's B, and then I want this vector that points the midway between the two. I mean, I kind of mentioned it earlier, but I didn't say it explicitly.
T equals half?
Yeah, t equals a half. So basically, what you could do is a half A plus a half B would do it. Or if you want to even write another way, you could write it as A plus B divide 2. So I just need to say this to you because I haven't said it to you formally. But this is what's called the midpoint. Yeah, it's just a small little note. Sometimes in the exam, as like part one of the question, they will get you started by asking you what is the midpoint of these two vectors. So that's it. Add and then divide by 2. So what have we done so far? We've done midpoint of two vectors, the angle between two lines, finding the line that connects 2 points, find the line that is parallel to another line. And so the last thing to do So I'll do it with an example. And the last thing to do is to find the shortest distance between C and the line AB. So I'll say that again. We want to find the shortest distance between C and the line AB. So there's two ways to think about it. But the way which you need to do it, because it's the way they ask you to do it in the exam, is by using calculus. So it should remind you of, I think last week we had a question where it said find the minimum of something. Remember that? It's a lot like that one. So anyways, to get started, first we need to find the line AB. So if you remember, the formula is A plus TAB, which is 2, 0, 0. Okay, so that's actually an easy example by accident. So that would equal 1 plus 2t, 2 and 1. So that represents the line A to B, and I called the point on it point or. So if you want to picture it, that represents these vectors that point onto the line. So again, when t is 0, it will point to A. When t is 1, it will point to B. When t goes to infinity, it will move past the B. And when t goes to minus infinity, it will move past the A. So you've got to imagine, don't think of it as like just one vector. Think of it as spreading out with different values of t. Anyways, there's the C. So what vector represents the distance between the line and C? Well, that would be this vector here, or C, because that's the distance between the two. It's this one here. Now, if you just go down here for a moment. Can you imagine if this moves down to minus infinity? What will happen to the distance of RC? It'll increase, yeah? And then if t gets bigger, and this moves up to infinity, what will happen to the distance? It also gets bigger, right? So there's somewhere on the line where the distance is minimum. So just if I was to draw it, what would be special about that line in relation to AB?
Straight.
Straight for sure, but the other key word I'm looking for?
Perpendicular.
Perpendicular. So C or B will be perpendicular there. So that's what we're looking for. So one way we could do it is we could try and find the T that makes RB and RC perpendicular. So if you think back, we have a very quick way. You know what, let me just make it clear here. I'm showing you two methods, so this is method 1. So if you think back, we have a very quick way of checking if two vectors are perpendicular. What is that? What's the quick check for two vectors to be perpendicular?
So see the gradient is inverse of that.
Oh, no. And tumbleweed. Something does equal 0. What is that something now? Quick way to check if two vectors are perpendicular? X equals 0. Oh no. Yes, that is the definition of perpendicular, yes. The quick way to check if they are perpendicular is... Stop. No. The dot product should be 0. Oh yeah, that thing. Remember dot product? I have a feeling that there's not much studying going on at home. This will be a problem come the final exam. So, the dot product RC dot RB should equal 0. Yes? Now, we have to find what RC and RB is, because actually this is R, this is C, and this is B. So it's not too difficult to find, just a bit of subtraction. So RC is C minus R, so that'd be 4 minus 1 minus 2t, 1 minus 2, 0 minus 1. So that's RC. And then RB will be B minus R, so that'd be 3 minus 1 minus 2t, 2 minus 2, 1 minus 1. And that should equal 0. Zoom out a bit. Okay, so let's just clean that up a little bit. That would be 3 minus 2t times 2 minus 2t plus minus 1 times 0 plus minus 1 times 0 needs to equal 0. So you actually end up with this: 3 minus 2t, 2 minus 2t needs to equal 0. So you get two answers. You get t equals 1 or t equals 3 over 2. So that's the first way to find the t. So if you use this t, you'll make the distance minimum. But the problem is we have two choices to choose from, and we know that there should only be one answer. So in a moment we'll see which one to choose. But before going on, I want to show you the second way to find the t. So the second way to find the t is, first you calculate RC, you differentiate, and you make it equal to 0. So RC would equal C minus R. You need me to go? Yeah. RC would equal C minus R. Okay, can you read out what was the C, please? What was the C?
410.
410. Okay, and then minus the R. So that's minus 1 minus 2t, minus 2, and then minus 1. Magnitude. So magnitude 3 minus 2t minus 1 minus 1. Okay, and magnitude again, so that'd be square root 9 minus 12t plus 4t squared plus 1 plus 1 equals square root 11 minus 12t plus 4t squared. Scroll down a little bit. Now, if you think back to the last time, I said if you want to find the minimum or maximum, you make the derivative equal to 0. And the square root means you have to use the chain rule. But in fact, like I showed you last time, if you didn't put the square root in, you'd still get the same answer for the location. So in fact, we can just ignore the square root. So derivative will be minus 12 plus 8t equals 0. So therefore, t would equal 12 over 8, which is 3 over 2.
Sorry, how do you get 9 minus 12?
That's square in this term here. Now what's happened here? we only have one answer. Whereas previously we had two answers. So I think it should become clear that we need to take this answer and reject this answer. But at the moment, I'll show you how you could have worked that out without having to do the second method. Although, if you did the second method, the advantage of the second method is that it should only give you one answer and you have no choice to make. Whereas with the first method, you get two answers, so you have to choose the right one. Okay. So, what I'll do now is I'll put my answers back into my OR here. So where's my OR gone? There it is. So here, whoops. First answer is 3 over 2. So if I use 3 over 2 for my OR, I'd get, this would be 3 over 2 times 2, which is 3, plus 1 is 4, 2, 1. And then if I was to use, what was my other answer? 1, I'd get 3, 2, 1. Sorry, I think that should be 4. I put in 3, this should be 3, isn't it? No, sorry. 3 over 2, 2, yeah, 4, 2, 1. Yeah, that's right, okay. So what you've done now is you found the OR. So all we have to do now is find the distance between OR and C, because we've now found the perpendicular one, the right one. Okay, so this is the OR, which is the one that you want to make the distance minimum. So we have to find the distance now between OR and C. So that would just be C minus OR. So, okay, the first one, OR C will be C minus OR. What was the C? It was 410. So if I do C minus OR, that's 4 minus 4, which is 0. And then 1 minus 2, which is minus 1. And then 0 minus 1, which is minus 1. And then this one here, if I was to do that one, you'd get C minus OR, what was C? 410, okay. So 4 minus 3, which is 1. 4, 1, 0. So 1 minus 2 is minus 1. And last one, 0 minus 1, minus 1. Is that right? 4, 1, 0. Yeah. 4 minus 3, 1 minus 2, 0 minus 1. Okay. So far both answers look good. The first one would be square root 2, and the second one would be square root 3. So we still don't know which one to pick though. Now, this is the problem when you do the first method, because it's not clear which is the right answer. Whereas with the second method, we only got one answer. What was that? Which one was the 3 over 2? So we know that this one here should be the right answer and this one should be the wrong answer. But still, it's not clear why. Anyways, the reason now that you would have to choose the first one and not the second one is, let's see, where's it gone? It comes down to this step back here. If you were to take your two answers and put them back into this step here at the beginning of method 1, this one will be fine, but if you were to put in 1, what would you get? You'd get 1 minus 1 minus 1, and here you'd get 0, 0, 0. So this is the reason you don't use 1. It's because it makes this vector here 0. And that doesn't really make any sense. The reason that doesn't make any sense, if you look maybe here, you can find the angle between two vectors, but if one of the vectors gets smaller and smaller and smaller and then becomes 0, 0, 0, then it's not really making any sense to ask what's the angle it makes with this. Now, this is the problem. When you do it, the first method, you're going to have to worry about that. Why did I get two answers? Why is one of them wrong? Come on, Brendan. But with the second method, you get only one answer, and so you don't have to worry about why is there a second answer, which is the right answer, which is the wrong answer. Okay? So, although the second method might sound longer because you have calculus in it, and the first method just has a dot product, the first method I think will end up being longer when you have to consider which of the two answers is the right one and which is the wrong one. So my advice would be to use the second method if possible. Okay, so that's the answer here. So reject this one. Question, yeah?
What if you don't make this one?
Say again?
What if you don't make this one? Just so you necessarily get into this one. I see but I already told you.
Yeah. You probably should have done that before looking at each answer. I just wanted to really make the point that just looking at the answers it makes doesn't give you the... I suppose if you think back to calculus, sometimes you'd put the answer in and you'd say, oh, that doesn't make any sense. What I'm saying here is that both answers look like they could be right. So my point I was just really making was, you can't tell from the answer which is the right one and which is the wrong one. Because both root 2 or root 3 both look perfectly fine to be the answer. Let me just have a look if there's any other examples. Now you see this I've actually spread over a couple of exercises. So let me see, where's this start? Okay, so we'll practice a little bit from each. So let me just stop this first.